Hey, physics peeps. We're going to talk about amplitude and how we find it out. Uh, you're going to be looking at a lot of different information, and you need to be able to pick out what the amplitude is for a wave or an oscillation based off of the information that you're given. We're going to look at a few different examples of that, and we're going to look at this first. So when we talk about amplitude, it's the size of a wave or size of a cycle. It's like how big is it going from top to bottom. Like you look down here at the bottom, we have a wave that goes up and down. The amplitude is how high it goes. The higher that it goes, the more amplitude it has. The lower it goes, or not as high it goes, we say it has less amplitude, all that stuff. But the size of it, it's really this thing. This is the key. It's half of the size from high to low. So when we look at this cycle, going up and down, back and forth, it's really going up to a high point and down to a low point. The high point it's getting to is right here. That's going up to over here on the side. It says it's going up to 20. And then when it gets to its lowest point, it's getting down to negative 20. You can think of this in a couple different ways. One, when we say it's half of the high to low, really it's going a total of 40 centimeters from top to bottom. But that's not the amplitude. The amplitude is only half that. So the amplitude we say is 20 centimeters. And that's kind of it. You can also think of it like an equation, and you can feel free to use this equation on quizzes and tests, but you're not going to be given that equation. You have to know what amplitude is. And if you know what amplitude is, it basically tells you what it is, what you do. It's half the total distance. It's half high point minus low point. So even if you do this, the high point, we said it got up to 20. Minus the low point, it got down to negative 20. And if you subtract a negative, you're really adding. It becomes 40. And it's half that. You still get 20 centimeters. So either way, it works out. We're going to look at just some other examples here really quick of amplitude, and you'll kind of see where that goes. But if we do look at a pendulum that's swinging back and forth. Here's a pendulum, kind of like in a clock, that swings back and forth. This one also swings from one side to another. It starts here, it ends here. It's kind of like here's our high point. Here's our low point. So it's going this far one way, this far the other way. It's going from 20 to negative 20. It's really the same thing. The total distance is 40 centimeters. But that's not the amplitude. It's only half that. So it's 20 centimeters. When we look at other examples, and like this pendulum, remember when we find amplitude, it's half the total distance. We look on the ruler, it's going from a distance of 0 all the way to a distance of 2. The amplitude's not 2, it's half that. So the amplitude is 1 centimeter. We look at an example like this. We have a ball that's going from one side to the other on this little kind of like a half pipe, and it starts here at A, it's rolling to C, and then it comes back down and goes back and forth. But when we end up amplitude, remember it's not a total distance. It's saying that from here to here it's 9 centimeters. That's the total distance. But the amplitude is half that. So the amplitude is 4.5 centimeters. When we look at something like this, we have a spring. It's starts here, and it bounces back and forth like it's kind of bobbing up and down. It's really creating kind of a wave on this as well. And it goes up to the highest point. It reaches 20 centimeters. At its lowest point, it reaches 40 centimeters. It's not 40 centimeters for the total distance. You got to watch it, where it started, where it ended. it's only a difference of 20 centimeters between the high point and low point. Again, that's not the amplitude. It's only half that. And that's the key thing you got to remember is when you find the amplitude, it's half the total distance. It's the same thing each time. It's pretty easy going, and students find this one pretty easy to find, but you guys got to watch out for things like this problem as well. When you have this wave, when we say high point, low point, well, the highest point it's reaching is up to here, 10 centimeters. The lowest point isn't 0, it's actually 2 centimeters. So the total distance here is 8 centimeters, but the amplitude is half of that. So half of 8, and it's 4 centimeters. So I hope this video helped you out. Feel free to reach out to your teachers if you have questions. But remember, amplitude, it's half the total distance.